Good evening. Very happy to welcome today's speaker in our alumni leadership lecture series, Ajit Narayanan, who's a 2003 graduate from IIT Madras, and he's the founder and CEO of Invention Labs, which is located in IIT Madras Research Park. I'm sure that you have seen his name a few times in the press, in various media. Has been winning a few awards for his innovation and for his the products that he has been designing and selling. In particular, Avaz AAC, which is an affordable tablet-based communication device for people who are speech impaired. It's an assistive device aimed at the Indian market, which allows people with speech disabilities such as cerebral palsy, autism, intellectual disability, aphasia, and learning disabilities to communicate. Also available as an iPad app, and it's mainly aimed at children with autism. In 2010, Avaz won the National Award for Empowerment of People with Disabilities from the President of India. And in 2011, he won Innovator of the Year Award from MIT Technology Review for the creation of Avaz. In 2013, Ajit gave a TED talk at the TED conference in Long Beach, California, about his research. He is a prolific inventor with more than 20 patent applications. Research interests are in embedded systems, signal processing, and understanding how the brain perceives language and communication. In addition, I've also known Ajit. I think pretty much I came back to IIT Madras in 2004, and he has been active in various alumni-related initiatives. I think he actually worked on a coffee table book, which I hope sometime will see the light of day. And during his college days, he wrote the Code of Ethics, right? Code of Conduct, yes. Which is still occasionally brought up as a model for future such codes. And maybe he'll touch upon all of that in his talk. Welcome.
Thank you. Thank you all for having me here. I've given a few talks in the last few months, so I'm trying to find a theme which is still, something which is different from everything I've spoken about so far, and perhaps try to be a little provocative in the title of the talk as well. Usually, when people introduce me with the technical work I've done, the innovation, the patents, and all of that, many people get impressed. I think my objective in coming and talking to you today is to tell you not to be impressed by these things. And I'm going to kind of demolish the introduction which Professor Nagaraj very kindly gave me. I am an entrepreneur and also an innovator. I passed out of IIT Madras in 2003. I was a dual degree electrical engineer. And I'm a very passionate engineer. I really get a lot of satisfaction and happiness from designing things, making things work, coming up with new ideas, seeing these ideas in action. And what I'm going to do today is to actually go through about 7 or 8 innovations which I had done in the last 6 or 7 years. And I'm actually going to point out in each of those cases how there are factors beyond technology which play a critical role in making something successful or even making something relevant for that matter. I'm very happy to see DC here. DC, an alumnus of IIT Madras himself. I remember the first time I went to meet him, I was a hardcore innovator, with an innovator mindset. I would do something only if it was new, novel, interesting, innovative, inventive, and so on. And DC told me a very interesting thing, and DC, I'm taking the liberty of quoting you. He said, when you run a business, technology is like a pickle, which you add to it. You can't make an entire meal of it. It certainly adds flavor to what we are doing, but it's something that you should add on top. I think for IITians, and especially for those of you here who are looking to become entrepreneurs, it's an important lesson to reinforce with examples, because otherwise, we tend to have the mindset that if it's something new, it should be something good. So here I'm going to talk about that. I've actually got 8 examples. I'm not going to show you any slides with photographs of my products or anything like that. I'm just going to talk, and I'm also happy to take questions in the middle of my talk if any of you has a pressing comment to make or a question to ask. But I'm just going to share some stories with you, and we'll have a interactive session after the talk is over, and I'll be happy to answer your questions. Let me start with the 28 patents which I have. The majority of these patents, about 25 of these, were actually filed when I was working in a company called American Megatrends. Just after I left IIT, as soon as I left IIT, actually, I was placed as part of the campus placements. I was placed in this company in America called American Megatrends. Many of you may be familiar with the company. When you switch on your computer, you see a red triangle which says AMI BIOS. And AMI stands for American Megatrends Incorporated, and they were my employer. Now, AMI actually has basically, it's basically a company which makes computer chips, actually makes firmware for computer chips, primarily in BIOS. But about a year before I joined them, they had an enormously successful sale of a specific product vertical that they had made. Okay, so they used to make these cards, computer cards called RAID, R-A-I-D. RAID is used for high reliability storage on disks. So instead of storing your data on one hard disk, you would actually mirror it across multiple disks. And AMI was the world leader in that, and they had sold that division just before I joined for about $300 million or something like that. Really successful acquisition. And that particular division, the RAID division, was founded, it was basically entirely created by a gentleman called Paresh Chatterjee. Now, as part of this acquisition, Paresh left AMI and he went and joined the company which had acquired that division. And about a year after I joined AMI, he was brought back. He came back in order to build a storage server team. So we were actually building storage servers, storage systems. Now, the founder of AMI is an IIT Madras alumnus. His name is Shankar, and he passed out, I think, in 1972. Of course, I got to know him over the period of the 4 or 5 years that I was there. So Shankar's idea was, with the storage team that we were trying to build in AMI, he wanted to actually replicate the success of the RAID team. So he was actually, looking to acquire a large market share, become number one in that space, and then probably sell the company. And at that time, it had become very clear to him when he was selling LSI, when he was selling the RAID division to a company called LSI, it became very clear to him that what was really being valued, substantial amount of valuation was being given to the business and the commercials and all that, but also a substantial value that was being generated by intellectual property. And this was actually a revelation for him, because when he started the company in 1980 or 1981, this concept of selling IP was actually not as big as it is today. So there was a very clear mandate from the top, saying you should, when you're telling Paresh, who was heading the storage division, while you're building this business, try to create as many patents as possible, try to be as innovative as possible. Now, Paresh was, I would say that he was the one that really taught me serious engineering. Till then, my engineering was limited to, playing around in Shastra and C5 and all of that stuff, whatever version of it was available then. But, under him, I really learned a very critical lesson. On day one, when we started that team and Paresh came back and, we had a team of maybe 6 or 7 people, he said, let's look at who are our competitors, and then we had a list. And every day from that day onwards, he would come up with an idea that would put us on top of the number one. He didn't have his sights, we didn't even have a product, and we didn't even have an idea actually about what we were going to do. But it was very clear that he wanted to be number one in that space. So every single day, he would think of inventing, and he would say, before you go to sleep in the night, just think to yourself of what have you thought new that day, and make a reaffirmation to yourself that you are going to come up with something new every day. For me, that was a really enriching environment to work in, because almost on a monthly basis, we would come out with a lot of ideas, and no idea was considered too outlandish or too wacko for us to explore. And out of these ideas that we had, we came down to a very, very interesting set, and we filed patents for these. Now, I should tell you that in AMI, this particular team had only 7 or 8 of us, and so I had the responsibility of actually writing the patent applications. I think that's the reason that I have so many patents. I got the chance to really put my name on a lot of inventions. But I think the point I'm trying to make here is a little more deep than counting the number of patents. Over the 5 or 6 years following, my departure from American Megatrends, when I came back to India and started the company, they had a number of competitors that had actually beaten them in the market at that stage. And very interestingly, the competitors that had beaten them were not necessarily big companies or anything like that. In fact, I still remember there was a Korean company that overtook us in the market and took away a really large account from us. And that company had a Korean name, and we actually went to, after that company had taken the project away from us, we were really very agitated. We wanted to know, what is this company? Who are these guys doing? We never heard of them before. And there was a Korean guy in the team, and he said, you know what the name of that company means? The name of that company in English, it means 3 of us. So the company which had 3 people, which actually took away a substantial amount of business from us. And they were acquired for several hundreds of millions of dollars. And same thing happened again and again. And AMI, for some reason or the other, we weren't really able to make a big success out of the product that we had. And I think, that's really a inconceivable thing for me at that stage. At that point of time, I thought, look, we're doing all this innovation, we're doing all this incredible research, and we're coming up with so many patents. There's no way that, we are not going to be number 1. It's not possible. You can't even think that, we'll be number 2. We have to be number 1. Nobody else has this much of intellectual property. But the sad reality is that it doesn't matter, right? And I think that's the message number 1 which I wanted to give you. Innovation is not a guarantee of success. Just because you have done a lot of new things doesn't mean that you're going to be successful. Now, after I came back to India, I had a chance to work again with a gentleman whom I had known before I left. When I left after my graduation from IIT, I had a cooling off period when I had to wait for my H1 visa. So I was able to leave only in October. So in the 3-4 months intervening between my graduation and October, I was working with this guy called Kannan. Kannan is probably known to many of you here. He runs a company called Vortex. He's a genuine innovator, real mechanical genius when it comes to coming up with new mechanisms and all that. And he had actually come up with this very, very interesting mechanism that would help dispense currency. And he built a company out of that to make a low-cost ATM. This ATM was a marvel of frugal engineering, right? I mean, the cost of this ATM was 1/100th. The mechanicals was 1/100th of what was available in the market. And a typical ATM would consume 1,500 kilowatts, 1,500 watts of power. This would consume 3 watts. You could run it off a solar panel, really. It was a marvel, really. And I helped him during those 3-4 months that I was here. I was working as a project officer in IIT Madras, and I helped him to build some of the early prototypes of the electronics and all that. Now, when I came back to India and started Invention Labs, I dropped in on Kannan just as a courtesy call, and I wanted to find out from him if there's anything that I can do to help, with the machine. ATM had become substantially improved at that point of time. So he said, look, we are facing a lot of bugs in the software. The ATM has become much more complicated now. There are lots of different motors, lots of sensors. The note is actually fed from a bin and it's taken somewhere, and then there's a lid which opens and closes. So there were about 20-25 motors in it, lots of different sensors with LEDs and lights and all that. And once in a while, inexplicably, the code would hang, or it would, there would be a problem with it or something. So he said, can you help me just clean up the whole thing and rewrite the code? There was a very interesting innovation which I actually developed at that stage. What I found out was, you can't really. So I assume that pretty much all of you here know coding in some form or the other. So when you write a computer program, it actually is a very good model. If you look at a computer program language like C or C++ or Python or any of these languages, it's very good for representing a kind of a sequential process, right? You do one thing after another, and then you can branch and you can loop and you can do all kinds of things. But that's not how a machine works, right? I mean, a machine has a lot of independently operating units which are controlled by a central processor. So you have motors running here. At the same time, some motor will be running somewhere else. Some light will be going on somewhere. Some sensor somewhere will be sending a signal. Some timer would have expired. So lots of different things happening, and we tried very hard to clean up the code. It was written in C on a DSP, but we were just not able to get very far with it. It's just, however hard we tried, we were not able to really distill. You look at the code, you can't actually understand what's going on. It was so complicated. And then it struck me. I had a conversation with this other IIT alumnus, a senior of mine by 2 years. His name is K.S. Sriram. He's a brilliant computer science guy. And he told me, I think the basic problem here is that you're trying to use the wrong language to solve this problem. He said, if you find that C is not good enough for you, don't don't program in C for this kind of a problem. Come up with your own language. And that was a fundamental paradigm shift in my head. And I worked for about 3-4 weeks continuously. And I came up with a new programming language. It's a programming language that was built specifically to write code for mechanical systems, electromechanical systems, where you have an array of motors, sensors, these robotics kind of applications, and you have a central processor, a single chip, which is actually controlling all of these together. At that time, the big news was all about, in the computer world, everybody was talking about .NET. Microsoft's .NET was really big at that time. So we were thinking of a name for this thing, and we started calling it .mech. Then we started using it for a number of different projects. And so we decided it's not just for mechanical system, it could be really used for any product. So the final name that we gave it was called .product. And so this is a very interesting computer language. What we did was we designed a system that would actually, you would actually program state machines directly. So you would have all these independently running state machines within your computer program. And each of these state machines would be able to trigger various actions. So it was a completely event-driven kind of a program. I'm not going to go into the details, but it's just a very interesting system, and it was really beautiful because what you could do is you could simulate the entire thing on a computer. You could see how it flows. You could actually record all the state transitions, and you could play it back. So if something happened unexpectedly, you could actually trace back the entire history of the program by just recording the states. You could do all of these things, and it was a real a masterpiece because in my own opinion, because we had this block of 50 files which consisted of this how the ATM operated, and when we converted that into .product, it was 1 page long. The entire code that ran the ATM was just 1 page long, and I wrote a compiler, which would convert the .product code into C code. So you would get back those 25 files or whatever it is, and then you could compile that and make it run on your computer. So we did that, and then I was very excited about it. Obviously I was very excited about it because you could take this huge, complicated, code base, and then you convert it into this 1 page, which really you just look at it and everything makes perfect sense. And so I tried to market this as a product, right? I went around to various people and I tried to sell it, saying, what about this as a product? Will you buy this? I went to big companies that were working on mechanical systems, robotics people, and then I learned a very important lesson. Everybody had a solution like this in-house. It wasn't perhaps as elegant or as as new as what I had developed, but everybody had some hack or the other. Everybody had a set of libraries. People were using PLCs, so that they had ladder logic. Some other people were using some other system. They had some other internal solution. But I thought that I was the first one to find the problem and solve it. If you are designing a complex mechanical system, you will always find this problem. You always run into this issue that your code is unwieldy. And so everybody has some kind of a solution for it. I think that's when I learned this really important lesson. Just because it's innovative, it doesn't result in a product, right? You have to actually study the competitive environment. You have to see what other people are doing. Is there really a demand for what you're doing? What is the effort involved in actually using what you've done? And then make, if there are enough people who say, yes, this exact solution will work for me, that's when you can make a product out of it. Otherwise, it still remains, a specific innovation for a specific task, which need not be monetizable in its direct form, So this is important. Innovation is not necessarily something which you package and sell as a product. It's often something which is tucked away somewhere in a tools cabinet and which you use for developing, your own thing faster and better. The third example I'm going to give you is the work that I did for this company in Chennai called ProTech. It's also a company started by 4 IITians. It used to be, the textbook company. Everybody used to point to ProTech and say, look, this is what innovative engineers coming out of IIT should be doing. And they're actually a fantastic company. I really love the thing they do. They basically build machines. They build printing machines, metal working machines, machine tools for various factories and stuff like that. Now, one of the products that they had was a laser cutting machine. I guess many of you may have seen a laser cutting machine, at least pictures of it, if not in person. But the idea is that you have these sheets of metal, right? You have sheet metal. And you use a laser to actually trace patterns on this sheet metal. So you have a really powerful laser, like a carbon dioxide laser or something like that, maybe a 1.5 kilowatt or 2 kilowatt laser. And if you have the right kind of optics, you can actually focus it to have very, very high amount of intensity of power. And at that temperature, the metal will melt, and then you'll be able to cut patterns. Now, Protech had started a new line of laser cutting machines. They had just started making these laser cutting machines. And they were doing these machines basically by getting components from various people and assembling them together to create the machine. Now, there is a critical component in this which they were importing, and let me tell you a little bit about what that component does. When you have a laser which is being kind of aggregated in order to cut metal, you need to be able to very precisely have it focus on the surface or maybe just under the surface of the metal, right? Because if it focuses underneath or above, then the spot becomes large and the power density becomes much less, and so you can't cut. So you have to focus it exactly there. Now, any sheet of metal which is big enough, it will have internal, imperfections. So you will never be able to have a perfectly flat surface on which you can focus. So as you are cutting, you will have to measure how high your head is from the sheet, and you have to move it accordingly in order to maintain exactly the right focal distance, right? So the head has to be lens, to be precise. The lens which is getting that light focused has to be at a very precise calibrated distance away from the sheet, right? It has to be that focal length away from the sheet. And there are very sophisticated mechanical systems that do that. And in fact, these guys were importing one of those mechanical systems. It would be basically the head, the laser head through which the laser light would come, that would have a small leg on the side. And this leg would be a spring-loaded sensor which will drag along the sheet. So you keep dragging this thing along the sheet, this sensor will keep moving up and down, as the undulations happen. And they were using that, and they were basically buying that from a company in Germany for about 1.5 lakhs, just that one sensor, and they had incorporated that, and they were making these machines and selling them. But this 1.5 lakhs was always an irritation for them, that for something so simple they have to spend this much money. Of course, the machines were expensive, 1 crore or so, but still it was not very pleasant for them to spend that kind of money. So when I went to them, I told them, look, I'm setting up this company, we're doing inventions, we call it Invention Labs. They said, okay, why don't you invent a sensor for us? And we tried a number of ideas, and then I had this, light bulb that went off my head, and I said, there must be better ways of sensing distance. And what's a good way of sensing distance? A good physical quantity that varies very, very sensitively with distance is capacitance, right? So you look at a parallel plate capacitor, and you have this, AE by D. So it varies as 1 by D. So in fact, the smaller the distances are, the more accurate this is. And so I was thinking to myself, why don't we use capacitance to do this? And actually when I went back, and I was very proud of that idea at that stage, but then I realized that there were other people who had come up with that concept, and they'd come up with capacitive sensors, which were also equally expensive, 1.5 lakhs, 2 lakhs. But then at that exact moment, this was in 2008, 2009, there was something else very interesting that happened, and this was the smartphones and tablets came out. So the iPhone, for example, came out in 2008. And working in a completely different world, away from mechanical engineering, away from machine tools, there were this group of people who had come up with chips that could detect capacitance to very, very accurate levels because they wanted to use that in touchscreen controllers, right? So the two things kind of went off together in my head, and I was like, wow, maybe we should use this. And I worked with a company that was making these touchscreen controllers, and we modified one of those in order to make a capacitance sensor for distance. And it worked beautifully. It worked phenomenally. I mean, we were able to detect distance with an accuracy of 25 microns. And you know what the best part is? The best part is that when you buy a smartphone, how much do you pay for it, right? And how much of that goes into the touchscreen controller? This chip cost 2,000 rupees, right? And this entire system, ruggedized and everything, we were able to do it for 10,000 rupees, right? Instead of 1.5 lakhs. And so this company was incredibly happy. I mean, I think overall we must have billed them about 15-20 lakhs for developing this. And in the first 10 machines that they sold, they made back all of the money that they had invested into the research and development. I hold this up as a great example of innovation because it's a very clear short-term commercial problem, right? You invest 20 lakhs into it. You make something which is which reduces 1.5 lakhs for every device that you make, and then very, very clearly what the payback period is. It's very short, it's very tangible, and it's very sensible, for you to embark on that activity. And so this is a great example of where innovation does work, right? A period of maybe 6 months, 9 months, cost of maybe about 20 lakhs or so, and a payback period of less than half a year. Works brilliantly, worked really well. But let me give you an example of something which didn't work, right? About 2008, 2009, we embarked on this complete misadventure, which almost sank the company. There's this organization, I guess most of you are familiar with Avin, which is the milk cooperative in Chennai, and there are similar milk cooperatives in every state. We worked with this milk cooperative in Kerala called Milma, right? They're the equivalent of Mother Dairy or Nandini or whatever, right? Now, these guys had a peculiar problem. They found that after milk had been liberalized in some sense, there were lots of private players who were also competing, distributing milk. And the thing is, when you distribute milk, you typically give it to a local distributor, and that guy will distribute milk in his locality. Now, Milma's milk price was fixed, so it was controlled by the government. You had to sell it at 15 rupees, and Milma would sell the milk to the distributor at 14 rupees, so the distributor would make 1 rupee profit. The private players didn't have any such limitations, so they would sell their milk for 16 or 17 rupees, and the distributor would make 2 or 3 rupees, so double the profit that they would make with Milma. So what would happen is, they would have these refrigerators. Some of these refrigerators even funded by Milma, but they would never keep Milma milk inside it. They would keep the Milma milk outside, and then they would keep the milk of the competitors. And so when somebody insists saying, I want the low cost milk, give me the Milma milk, the Milma milk that they give them would most likely be spoiled. And so Milma was, getting this problem that unless they controlled that last mile of distribution, nobody was really interested in support. None of the distributors were really interested in supporting Milma. So Milma asked us to build a milk vending machine, right? Not a liquid milk vending machine, a milk sachet vending machine. The milk sachets that you get, they wanted a vending machine that could vend that. Now, this was a really very interesting technology problem. At that point of time, I had a colleague of mine, his name was Preetham, a few years junior of mine from IIT, who was an extraordinarily brilliant mechanical engineer. And he loved this problem, it's a beautiful problem. You have these sachets of milk, and the thickness of the sachets is in microns, right? It's such a small, thin plastic packet. And even if you touch it a little hard, it would break, and you have to make this machine in which you can load this and it will dispense it one at a time. So it's really complicated, really amazing precision required. And he came up with this, very inventive mechanism which would actually dispense these milk sachets. I think the closest analogy I can think of it is, like the process of digestion, right? You have a pipe, and then, one by one you kind of push those things out. It was a very nice, very innovative system, and it worked really well. There were a couple of problems though. The biggest problem was it took us about 2.5 years to develop. The second problem was Milma had a very tight control on the price of this milk vending machine. They said you have to sell this we have to be able to sell this milk vending machine at 80,000 rupees. Now, 80,000 rupees seems like a reasonable amount of money to spend, because about 10-15,000 rupees would be in the refrigerated container itself. The whole vending machine is refrigerated, and we thought, okay, 60,000-70,000 rupees, we can always find a way of making a mechanical system for this, which is correct. We could actually make a mechanical system for this entire thing for maybe about 50-60,000 rupees, but it doesn't include the cost of innovation, right? We spent 2.5 years in developing this, and a certain amount of money and experience and time and people and all that. But that margin, we didn't have any margin at all to be able to recover the cost of that. That was a problem. The second problem was, as you know, in Kerala, there are basically two parties in some sense, the Congress and the Communists. So when we started the project, the board of Milma was filled with people from the Congress, and they were like, wow, yeah, we should do this, automation, whatever, innovation. And when we finished the project 2.5 years later, the board had changed very subtly, it had become a red board in some sense. And immediately, when we finished the project, we delivered it, people were like, why did you build this? We're going to be putting milkmen out of work. We can't be anti-labor, we can't be anti this. And then they said, sorry, we don't want any more machines. We'll take this one, we'll put it up somewhere, but that's it, stop. And we had this, intellectual property, this white elephant, very literally, on our hands. We didn't know what to do with it, It's such a niche market. There are so few milk cooperatives. There's just one for every state. And very few of them are actually willing to take a bet and try something new. And there are so many vested interests in this. And we had such a low cost, if you compare it to the Protec case, where every single machine they were selling, they were making 1.5 lakhs towards innovation. Here we were making 15,000 or even less. That was hardly the cost of one technician for 1 month, right? And we had to recover like 2.5 years of solid work that had gone into it. It just didn't make sense. We lost a huge amount of money there. Substantial part of my team left at that point of time. A really dark point in my entrepreneurial career in some sense. And I think this is a lesson that I learned from that. For low cost, I don't know. I mean, people talk about low cost a lot, and I'm sure that many of them are actually talking a lot of sense, but I've never seen it work. Low cost and innovation, I don't know what's the formula to make them go together. You're cutting down your profit margins, you're keeping your sliver of margins very, very small. It's very difficult to justify using that small sliver of profits to run serious innovation. And especially for these niche, slow markets, which will take, even if these guys had been successful, even if the communists had not come to power, even if we had put these machines, it would have taken maybe 10 years for it to become scale. These guys would have probably put up 5 machines, then they would have put up 15 machines. Then after 3 or 4 years, they might have put up 100 machines. And that's actually happening to the ATM right now. The ATM that Kannan and I designed way back, it's only now, 10 years down the line, that they're seeing large scale. And they were funded really well, and so they're able to sustain. But otherwise, it's just not possible. For a slow, small, niche market with a low-cost product, innovation didn't work for me. It was a disaster, right? So that's an example of where it didn't work. Let me give you another example of innovation really for its own sake. We were doing this work for this client, which was in, they're a small company in Bangalore, and they were making energy metering systems. The idea was that you have a room like this. You don't actually have to switch on all the lights. You don't have to put the AC on at a certain temperature. If there were only, say, 25 people in this room, then this AC would be like way overused. So you probably want to have an adaptive system. So these guys wanted to do smart energy. They wanted to build a system of sensors and switches and controls for temperature and controls for scheduling and timing and all that. They wanted to build a suite of products which would basically be able to control like temperature in a room or something like that, right? Or in an entire building, like in a research park, for example. If you could control your energy use, you probably cut energy use by 1/2. And so these guys were looking at that, green buildings and all of that. Now, this particular problem, they came to us and said, look, we need you to make the entire solution for us. We want you to make all the parts of the product. We want you to make the sensors. We want you to make the switches. We want you to make the systems that control the ACs. And we want all this to be wirelessly linked together. And we want a software interface that you can use to actually look at everything, like a dashboard, figure out all of the stuff that's happening and all that. So we liked the project a lot. It was a fun project. You harvest energy from the line itself. You take a little bit of energy, you run the whole thing, you do this wireless communication in a mesh. It was very, very exciting from a technology point of view. But even when we started the project, I had an inkling of a doubt about whether this is really required. I asked them, don't you have these things readily available in the market? And these guys are like, yeah, we have some things in the market already, but I think we can make a better product than what is there in the market, just because in the market it's all commoditized, it's all at a low level, low quality, high price. We'd have to import and export, and I think the underlying theme in all the jargon that they were throwing at me was this. We didn't start this company to do the import-export business. We started this company to do innovation. We started working on these energy solutions because we want to create our own innovative solution. We don't want to just resell from China or whatever it is. Fair enough, so we built it. It took us a while, but we built a really nice solution. We built this very nice mesh networking architecture, a very nice messaging protocol, and it would scale. If you could put in repeaters, it could scale across entire buildings, and you could access it from anywhere in the world. So you would have a web interface for the whole system and all that. And it was really nice, and in fact, it is doing quite well in a few places. Like I think there's this big mall called UB City in Bangalore, and that's one of the big customers for these guys. So it's actually doing pretty well. But if you look at that company and you compare them with competitors that they had, which are other startups we started at the same time, those guys are being beaten by people who are doing exactly what these guys didn't want to do, which is import export, right? What these guys did was that they thought they could build a cheaper device for a higher quality with more innovation, and all of that is correct. Tick box, yes, it's cheaper, maybe by a couple of thousand rupees, but whatever, it's cheaper. They have better control of the costs. They have better control of the quality. They have better control of what features they can add in the future. But there were these other guys who came into the market. They would buy these kinds of devices from China or from other parts of the world, and they would put them together. They would assemble them. They would install them. And if something went wrong, they would send an electrician to fix it. If these guys wanted something better, they would find another product from China and they would put that in, right? They played the entire game on supply chain. They played the entire game just on logistics, right? They didn't even have an engineer in their teams, right? There are 5-6 companies like this, not even one. Plenty of companies that were working in the smart energy space. Most of them had no engineering background, and they completely took over the market, right? And I think that's a very critical point, that these guys went wrong. I mean, I see many entrepreneurs from IIT, some students even, maybe even some of you in the audience have come and spoken to me and said, let's do this. I have this idea and I want to build this thing, and we should build a company to do this and all that. And there is this fundamental resistance against buying somebody else's product and selling it as a solution. I think that's fine. You don't have to buy and sell. You don't have to do the import-export business. But you are competing against people who are doing that. And there has to be a very clear reason why you need to innovate when you have other solutions available in the market, where you can make other solutions work by the power of negotiation, by the power of putting labor behind it, by the power of building good relationships with your customers. Innovation is not a solution, and it should be the last option really. If you have something that you can't get in the market, you can't do by yourself, by building relationships. If it needs to be there, your customer is demanding a feature which nobody else has, then you innovate. Don't innovate just because you can build something, and it gives you that kick that okay, I built my own wireless mesh, whatever. That's not the reason to innovate. So that was the lesson I learned from them. So let me switch back into a positive example, right? So we do work for this German multinational that works on blood glucose meters. So I guess some of you may have relatives who are diabetic, for example, and if you have diabetes, you have to maintain good control of your blood sugar. So what you have to do is you have to poke yourself every day, and you have to take out a drop of blood, and then you apply that blood on a test strip, and you have this meter which will tell you what your blood value is, and then you either use your insulin, you use appropriate amount of insulin, or you just change your lifestyle so that you're able to control your health. So we were working with this company that is the biggest manufacturer of glucometers in the world, and they were facing a very common issue. The problem that they were facing is everybody was buying their meters, nobody was using it. So why was nobody using it? Because first of all, it's a painful thing. You have to poke yourself and all that. So it's not a pleasant experience. And the second is every day you have this daily, reminder really, which is telling you, look, you're sick. You made yourself sick. Why did you do this? It's almost like, the meter is nagging you on a daily basis, telling you, you're a loser in life. You have diabetes. So they wanted us to actually come up with a system. This was one specific project that we did called the encourage meter. So the idea was to build a meter that would encourage people in order to get them to have better, therapy effectiveness in some sense, better adherence to the therapy that they actually were going to have. And it's quite an interesting project. We tried a number of different technology ideas. Can we make the needle less pokey? Can we make the display less intimidating? Can we put a smiley face near the display, so that it looks good and all that? I'm not going to go into the details. It's still quite confidential, and we've signed an NDA with them. They're patenting a few of our ideas. But I'll tell you one of the things that we did. I read a few. Actually, when I went for this TED talk, I also had a chance to hear another TED talk by this guy called Dan Ariely. Some of you might have heard him, and I had a chance to have a conversation with him. This was all before this project started, but it was just something in the back of my head. He'd done an interesting experiment at MIT. So what he did was, he was trying to find out, he works on motivation, what motivates people to work, what motivates people to do boring things, do unpleasant things. And he had this very interesting experiment. So the experiment was like this. He had a sheet of paper, right? And the sheet of paper had printed letters on it, line after line after line of closely printed letters. And what you had to do is you would be given a sheet of paper, and you had to circle all pairs of the same letter, occurring twice. So if you have LL, then you would circle that. If you had NN, you would circle that. So basically, you had this big sheet, and then you had to do that. And you would be paid some amount, some nominal amount, say $1 or something like that, for every sheet of paper that you turned in with, the right stuff circled. And there would be a kind of a falling grade. So the first time you submit it, you'll get $1. Second time, you'll get 90 cents. Third time, you'll get 80 cents. So some exponential this thing. And it's a very boring task. And they were trying to measure how long it took for people to actually get sick of it and say, okay, fine, I don't want the money, I'm not going to do this anymore. So they tried this out with a number of different MIT students. And they tried this in 3 different conditions, okay. The first condition was, so I'm an examiner, I'm sitting here, you guys are the students working on this particular assignment. You come to me and you give me the paper. When you give me the paper, you write your name on it. So whatever, like Rajesh or something like that, and you give it to me. I look at the paper and I keep it face down next to me. Very simple, right? And then you can go back and do the next one if you want to. So you write your name, you give it to me, I look at it and I keep it here. The second condition is, you don't write your name on it, you just give it to me, I don't even look at it, I just take it and keep it here, right? And the third condition is, you give me the paper, I don't look at it, I don't even look at you, I put it straight in a shredder, okay? I mean, it's obvious, I don't have to tell you this, but obviously the people who were in the first case were more than the second case, which is more than the third case, right? They went farther ahead. But this is the interesting thing. This is a really interesting thing. The interesting thing is, in case 2 and case 3, the amount of difference was very minimal, right? So if you don't acknowledge that somebody has done something, it's as good as shredding their work, okay? So completely different context, completely different conversation with Dan Ariely. But then, when I started working on this project, we suddenly had this idea that maybe that's what we need to do. You're taking your blood glucose reading by yourself, you're doing your own this thing, whatever. So we came up with a very simple system where, your blood glucometer would actually keep beeping and it would keep showing you that number until you actually sent an SMS of that to a doctor, right? And the doctor would just reply saying, okay. In fact, that process could even be automated, right? So you're just sending your data somewhere and somebody else is saying, okay, fine. I mean, just an acknowledgement, not even a judgment about it. And it was amazing. We found, so these guys, they took the idea. They were a little skeptical in the beginning, but they took the idea and they implemented it in the US. They did a study, for about a year and a half. And they found that there was actually like 20% improvement in therapy adherence just because of this simple idea. It was a real revelation to me because it told me something very interesting. 20% is not a small number. And the beautiful part is, it wasn't even technology, right? We didn't even do, it's just an idea. They paid us a lot of money for it, but it wasn't even technology that we did. And that's the other thing which, I discovered. Some of the solutions, some of the best innovations are not even technology. They're just new ideas implemented in an efficient way. And they don't even cost anything to implement, right? So this is an example of an idea like that. Let me just close with a couple of examples from my own product, right? Some of you may know that I work on a product for children with speech disabilities called Avaz. Perhaps I should talk about a little bit about the innovation which goes on there and how that innovation contributes to the success of the product. Now, Avaz is a tablet app, it's an iPad app that helps children with disabilities to communicate. And again, I'm going to take the liberty of sharing some of the advice that DC gave me when he was mentoring me to set up a company around this idea. The first thing that we did, he helped me with this, and I did this along with several of my colleagues, is that we built this very detailed Excel sheet, which is a financial model of where the costs are and where the income is coming in, right? And this is a discipline that he kind of inculcated. And he said, you take the money that's coming in from your customer. A part of it goes into direct cost. So what is the cost of manufacturing? A part of it goes into electricity, goes into paying salaries of the people who are doing the delivery and all of that stuff. And then there's a remaining amount of contribution. And that contribution is what should be used for funding your R&D. So R&D is not a birthright of the product. When the product is born, it doesn't have the right that somebody is going to do R&D and improve the product. That R&D should come from profits that the product makes. The product deserves R&D only if it's making money for you, right? And that was a very, very important lesson for me because if you had given me the luxury of running a company without any checks and balances, I would have probably had 100 engineers, doing 100 different things, trying all kinds of moonshot ideas, and most of the ideas never even making it into the final product. But that's not what you should be doing if you're looking at entrepreneurship. Innovation should be driven by business needs. So how come we're still funding research into Avaz, right? We still develop the product, we still do R&D on a regular basis. In fact, we do R&D so regularly that it's considered, right now we even consider it as a variable expense, it's as an ongoing expense. It's not a capital expenditure anymore. And that's because in markets like this, and this is only one example of a market like this. There are many markets in which this doesn't hold. But in markets like Avaz, we have competition. And the competition is constantly innovating, right? And when a competition is always innovating, you have no choice. You have to innovate. You have to stay ahead of them. So actually, if everybody in my business was to stop innovating, we'd be all fine. We'd all have our market shares. We'd all be growing. The business itself would grow for everybody simultaneously and all that. But that's not the case. You have one guy coming in and starting an arms race of innovation. Then you have to keep up. So you have to be very careful that this arms race of keeping up with the competition doesn't end up bankrupting you because your financial model is not good. You have to, even at those high rates of R&D, in order to stay afloat with the competition, it still has to make sense on your Excel sheet. And I think that's the critical lesson that I learned with my mentors. Invention must have a financial and a market justification. If it doesn't have a market justification, if your competitors are not doing it, don't do it out of the goodness of your heart. Don't do it for your job satisfaction. It need not be done. It should not be done. It has to come out of that contribution towards the profit. The second thing is, if it doesn't make sense, if you think that you're going to be able to capture 100% market share, but you're going to be spending double of that money on your R&D, it doesn't make sense. It has to have a strong financial reason, and it has to have a strong market justification. And the final thing I'm going to talk about is this new innovation which I've come up with, and I'm only just putting that in the market now. It's called free speech. This is what I gave my TED talk about. This is what I won my MIT award for and all that. So it's probably one of the biggest innovations that I've made in some sense. Just to give you a small flavor of what it is, with Avaz is a picture-based communication system. So you take pictures and you put them one after the other, and you construct a sentence, and it speaks that out. It's a text-to-speech converter, but it's a picture-to-text, text-to-speech converter. It works really well for many children. But what I found was, while you can have a picture representing a word, there were very few attempts and no successful attempts that were made at representing an entire sentence or an entire meaning in the form of a picture. So after a lot of research, to give credit where it is due, done by IIT interns, we actually built a system which would allow you to make a visual map of an entire sentence. So, a way of visually putting various pictures together, joining them with certain relationships, with certain arrows and all that, so that this entire system would actually represent a complete sentence. And we built this beautiful translator that would take this, image of a sentence and convert that into an English sentence. So it was a combination of a visual grammar and a translator into English. Now, everybody I've shown this to has said, wow, this is disruptive. Nobody is going to be able to replicate this. It's just so new and so phenomenal, such a fantastic idea. Everybody has loved it, when I show it to people in the therapy space. But you know what? I'm having the hardest time of my life actually taking this product to market, and I'll tell you why. My primary market is the US, right? Most of Avaz sales actually happens in the US, about 70%, another 30% in Europe, and then maybe a little bit in India. In the US, Avaz fits into a very nice niche. If you have a child with a disability, that child would be admitted into a normal school, and in that normal school, you would have a therapist and you would have special educators, and a combination of special educators, therapists, various infrastructure, paraphernalia. They would be able to provide speech and language therapy for that child. And these therapists who actually provide these services, they go through a 4-year or a 5-year course on speech therapy in college before they come to the child. So they already know how to do therapy. And unfortunately, they know how to do therapy with an app like Avaz, but with something like free speech, they see the value in it, but they would never even know where to start, right? This is the classic, inventor's dilemma in some sense, innovator's dilemma. If you were to invent, say, a new car. Let's say we invented a car which could fly, right? I mean, all of us agree that it would be a revolution. It would be a fundamentally new innovation. Say that I could make a car which would fly at say 15 lakhs. It would be dramatic revolution, but it would be incredibly hard to take to market because you would have to see, okay, how are you going to give licenses for people to learn how to drive this? How are you going to have refueling, for this kind of thing? How are you going to do maintenance? How are you going to have drivers trained for this kind of thing? When you have a product, the primary value of that product can be clear, but how that product fits into the life of the end user is much, much more than just that one innovation. That's the problem with disruptive technology. It's a very seductive thing. You're really attracted to it because it's revolutionary, it's nice, it's new, and nobody else thought of it. It's really something which is very, very hard to say, okay, I'm going to keep it in the back burner. But unfortunately, that is the truth. And I want to leave you with that one thing. Innovation is one thing. Building a successful company is a series of small, systematic, disciplined steps. You have to be able to do things one after the other without losing track of your bottom line, without losing track of your resources, without losing track of what your customers are saying about your product, but not jumping headlong into innovation. And I think this is the last lesson really which I learned. If you have a disruptive technology, if you have a flying car, don't jump and start a company on that. Take it to market in a gradual way, in a sensible way, think twice, write a good business model, see how other aspects of life would actually be impacted by it, and get everything working before you can get your car in the market. That's it. Thank you very much. Happy to answer any questions. I'm sure a lot of you will have questions. But I mean, just to give you a disclaimer, I know a lot of people who have successfully innovated breaking these rules. So I'm just putting down my experience here. I'm happy to share details about any of these experiences. But if you have a great idea, do go ahead and try it out. Yes?
I just had one question about the last one, free speech.
Yeah.
The free speech technology. The problem with that is, how do you get people to get certified for that? Rather, they don't know where to start when they want to use it. Right?
Yeah.
So
that's correct.
it's like a pretzel and soda thing. You sell pretzels cheap, then you sell soda for a lot more money because once they get the pretzels, they need the soda.
Correct.
So would it be possible to start a series of coaching institutes that give you such a certification?
I agree.
And then
yeah, that's correct. And in fact, that reinforces the point I was trying to make. So you build this entire company thinking that you're making innovative products for speech and language and software. And then, before you know it, you're actually running a series of coaching institutes. This is exactly what happens when you're running a disruptive technology. The problem takes, the problem really starts controlling the business instead of the business controlling the problem. I completely agree with what you're saying, and it's a very nice insight that you have, and in fact, that's what we're doing. We're trying to develop training material. We're trying to work with, universities to see if we can get this as part of the syllabus. We're trying to see if we can make tutorials. We're trying to see if we can directly empower parents without going through the therapist. But we didn't really sign up for all that. When we made the invention, the hope was that, okay, we make this thing and then we put it in the market and then, we kind of become millionaires. It never works that way. Not with disruptive technology, not with innovation. I think the mic is not on. Switch it on. Yeah.
Hello?
Yeah.
Say someone wants to make a startup, and if he doesn't have his own idea or innovative idea, then how could the legendary companies in that field?
That's actually a very big question with a very big answer, but I'll give you a few hints. It's actually, this is actually the answer which I'm kind of cautioning you against. Don't think that if you have to compete against a big multinational or whatever, you need to have an innovative idea. In fact, I can guarantee you that if you have an innovative idea, that is definitely not sufficient to compete with a big multinational. I've seen, in fact, history is full of examples where multinationals have crushed a lot of innovation which they don't own. A good example would be Flipkart, right? So when Flipkart started, why do you think they were able to get so far when Amazon was in that space?
Cash on delivery.
No. It's just because they were in India and Amazon was not, right? It's, just physical presence is critical. And in vast parts of the world, we still have that. You need to have a reseller, mindset in order to be able to just take technologies from America or from China or whatever and bring them into certain parts of India where they don't exist. But that is innovative in itself, and it's not easy to do that. So that's one thing you can do. You can look for geographic exclusion, right? Where a certain part of, for example, selling cars, right? You could sell a car in a place which doesn't have a car dealership. It could just be an area of 10 square kilometers radius, diameter. But if they don't have a car dealership, it's quite likely that you set up a car dealership there, they'll make money, or a vegetable shop, right? That's the thing, I get this look whenever I tell people, you should start a vegetable shop. It's an honest commercial enterprise. It's just that people think that setting up an innovative company doing some semiconductor work and VLSI and all that is like a lot more meaningful in life than setting up a vegetable shop. It's not. I mean, it's all entrepreneurship. Ultimately, you make money, that's the crux of it. The second thing is just relationships. I mean, if you are going to be an agent selling insurance, for example, I think you need to have a strong relationship with a customer. Or if, for example, even if it's just Infosys, right? What does a company like Infosys have in terms of innovation? They have, I'm sure they have innovation in their processes, but nothing technological. Their skill is they have gone to the market, they've convinced people that, look, we can do this work for you at a price which is reasonable and a quality which we are able to guarantee. And they're able to build these relationships with all these big clients, and they're able to run an entire business out of that. So there are a number of ways in which you can make money. In fact, I would say that there are 99% of the businesses started in this world actually don't use innovation to make money. The 1% that use innovation get all the press, and so everybody thinks that that's the right way to do it. But that's actually the rare success. That's the difficult way to do it. Do you want to use the mic? We'll come to you.
Item number 2.
Yeah.
Not all innovation results in a new product.
Correct.
Not a product, a new product or a better product.
Yeah, that's true.
Because you got to innovate from somewhere, no?
I mean, I'll give you a great example, right? I read this in a comic, and I don't remember the exact details, but there is this really beautiful approximation that you can do. It's a work of genius, really. This approximation for 1 by x square, this calculation of 1 by x square. This calculation keeps happening again and again in computer science, because a lot of things are like they fade off in square law. This one guy discovered a very clever way to do that in one step, right? Typically, this is like a really complicated process which happens in the computer. It takes maybe 50, 60 cycles of your CPU to do this. One guy discovered a way to do that, just by doing an XOR with some other number or something like that. You can look up the details. And he found a way to do it in one step. And what he did with it? He didn't do anything. He didn't publish it. He was not an academic. He didn't file a patent, nothing. In fact, he was just a normal programmer who discovered this as part of his thing. Nobody even knows who it is. But when they made the Quake, there's this game called Quake, right? All of you know. When they made the Quake source open source, somebody found this approximation inside that. It's a work of genius. If this guy had been in academia, he would have probably won like an award or something for it. But he just discovered it as part of optimizing his game, and he put it in there, right? And so it didn't result. That didn't result in a product by itself. It was just a tool which he used in the right place, and it was incredibly innovative. A lot of innovation is like that. Yeah. Yeah, go ahead.
Actually, my question is, generally you have a company who sells innovative idea, and generally it is initiated by another company who needs that idea. So you sell idea in a consultancy basis. And in general, this pattern is followed. And so the idea once the necessity of the idea is generated, then only you create that idea and you sell it.
Correct.
But isn't it possible that I advertise my own idea, I create it beforehand, and I advertise it that you may need this thing. So you try to persuade the companies to buy your ideas. The thing doesn't happen.
It's correct. I mean, and in fact, the last two examples I gave were products that I myself have made and which I myself am advertising and selling. But that's the thing, right? I mean, you would think that in an ideal world, if you have a better product, you will have a better market, right? I mean, if you have a great product, you can advertise it, you can market it, You can put money behind, branding it, and then you will be able to get a large percentage of people to actually buy the product. In reality, that doesn't work. And in fact, I think that's the crux of my talk today. The innovation is the pickle on top of a lot of hardcore work that you have to do in advertising, branding, and all that, which you can do even if you don't have an innovative product. The problem is that you are thinking about innovation in an empty market. The problem is there are very, very few markets which are actually empty. The majority of markets in the world today have competition. It may not be another product which you're competing against, but it's an existing way of doing something already that you're competing against. And when you're competing against that, there are entrenched interests there. You have competitors who are actually trying to convince the market not to use your product. So your advertising is not sufficient, at least unless you have a lot of capital. Yeah.
Hi. I want to know, because we've known each other for a while now, it's almost been like 7 years or so. How do you think do you think 7 years back you would be giving a similar idea for innovation, the approach that you have now? Or how has your understanding of innovation or how it helps business processes and has changed over time? I'm saying that especially because I guess you've had the luxury of experimenting a lot.
Yes.
And many of us won't have that luxury and so on.
Yes. Yes, and it's true. I've also had the luxury of experimenting a lot on other people's money, because a lot of this has been projects that we did for other people. I think it's true, and I actually see that. Right, Amrut? I mean, both of us have interacted with a number of startups coming out of IIT, people who've just passed out and just started up, and I'm seeing that mindset again and again. That I have a new way of doing something. I have a new idea. I have a fantastic bit of intellectual property. Therefore, I am entitled to having a great company as well. I think I had that. Certainly, I had that attitude when I came into entrepreneurship. I thought that innovation automatically meant success in entrepreneurship, and it's unfortunately a lesson that people don't learn unless you actually go through that school of hard knocks in some sense. Experience, right? My technology mentor Paresh used to say, experience is the teacher which gives you the test first and then teaches you the lesson. I think particularly appropriate in this case.
Hello, sir.
Yes.
I want to ask that, suppose you have an idea in your mind, means how do you frame a timeline to do work on it? Because it's totally raw and you don't know how much time it takes to go on or to complete.
Good question. There's no direct answer to it actually, because it obviously varies a lot depending on what the idea is. I think the important thing is, even before you start working on the idea, you have to validate that it addresses a real need. Sometimes ideas, I'll give you a classic example from my own case. Ever since I was probably 25 or something like that, I've had this dream of making a, what I call a meals maker. The idea is that you kind of take this refrigerator kind of a system and you store all your provisions in it. And then you press a button and in half an hour, you'll get this complete thali, Andhra meals types thing which comes out. And I actually spent a lot of time working on it. With this friend Preetham, who's a mechanical genius that used to be my colleague, we actually built a system in which can automatically it'll make rice and it'll make sambar. Those two things we did. But it was a stupid idea. I mean, if I had gone and spoken to people in the market, I would have found that the market for it is actually very small. And even if I had successfully made that product, how many people would have bought it? Maybe a few hundreds, maybe a few thousands, but it's certainly not enough to justify investment into that idea. So even before thinking about the time aspect, think about the relevance aspect. Is it a good idea to work on from the perspective of actually running a business? With respect to time, see, there are two different things. One is these research ideas, right, where you know that if you solve a problem, it's going to revolutionize something, but you don't know for sure that a solution exists. The other is this development kind of a problem, where you know that the technology exists to do what you want to do, but you just have to have a project plan in place so that you do it properly. I would say that when you're building a company, you should only look at the second kind of problem. The first kind of problem, you'd be much better off doing it in a university setting or doing a PhD on it, where you have the luxury of time and somebody else's money. And even if you fail, you can still publish a few papers out of it. The products where you know that it can be done if you have sufficiently skilled people to work on it, those are the problems which are actually good candidates for starting companies with. I think Okay. Thank you very much, guys. Thank you for your questions. Thank you very much. Thank you very much, DC. Thank you. Thank you.